Explorer's Guide to World Weather. Introducing Earth. Oceans and air swirl around Earth. Ocean waters that wash the shores of North America also wash the shore of Asia. The breeze that blows Corton in South America rustles leaves in Africa's trees. Yet regions on Earth can be very different from one another. In some places, people never need a, a heavy coat. In other places, people never go out without one. Farmers pray for rains in some places. In other places, rain falls every day. Let's look at why different parts in our planet have such different weather. How scientists measure weather. How many words can you think to describe weather? Hot, cold, warm, chilly, rainy, sunny, snowy, foggy. The list could go on and on. All these words describe two things: temperature and precipitation. Temperature is how hot or cold a place is. Precipitation is moisture that falls to the ground in the form of rain, snow, sleet, or hail. To track the weather of a place, we measure two conditions: how hot it is, how wet it is. Climate is simply the, the average weather in a place over a long period of time. Weather information can be recorded on graphs. Look at the temperature graph below. Graph shows information on the weather in Sydney, Australia for the first 6 months of the year. The number on the left side show the degrees of temperature. Now look at the precipitation graph. It is very similar except that on the left side, the numbers show amount of precipitation in inches. By collecting weather information over time at many places, scientists have discovered that there are so many different climate patterns. Climate Field Guide. What determines Earth's climate patterns? It all starts with the sun. Sun warms our planet. This warmth is spread unevenly over Earth's surface. The equator is an imaginary line that circles the middle of the Earth like a box. Areas near the equator tend to be much warmer than areas far to the north or south, because Earth is shaped like a ball. The sun's rays hit Earth that at different angles to different places. The sun rays are most direct around the Earth's middle and least direct at north and south poles. Latitude. Latitude is the system we use for measuring distance north and south of the equator. The equator is 0 degree latitude. The North Pole is 90 degrees north latitude. South Pole is 90 degrees south latitude. The smaller than the latitude measurement, the closer a place is to the equator. The greater the latitude measurement, the farther it is from the equator. Climates at or near the equator are generally warm. Climates around the equator are generally cold. Elevation. Elevation, the height above or below sea level, can also affect climate. Imagine you are at the equator standing on a high mountain top. You will be in a cold climate. That's because the temperature of the high drops at about 3 degrees Fahrenheit for every 1,000 feet increase in elevation. Mountains can also affect precipitation. Air contains water vapor, water in forms of gas. Air tends to move around the planet in a certain direction, called prevailing wind. When wind runs into a chain of mountains, the air is forced upward. Where it is cold or cools, cool air cannot hold as much moisture as warm air, so air traps its moisture as rain, snow, sleet, or hail on the windward side of the side. Very dry regions caused by mountain walls are called rain shadows. Large bodies of water. Large bodies of water affect temperature and precipitation too. Water heats up to cools down more slowly than the surrounding land. As a result, large bodies of water act as a kind of solution on the areas of land next to them, keeping them from heating up or cooling down too quickly. Places near a large body of water experience mild winters and summers. By contrast, places located far from large bodies of water often have extreme temperatures, very cold winters and very hot summers. In those places, the air does not hold enough water vapor to insulate against the extremes of temperature. Ocean currents also play a part in climate. Cold water currents flow from the pole toward the equator. Warm water currents do the opposite, flowing from the equator toward the poles. Air above these currents slowly becomes the same temperatures as the water. Consequently, if a prevailing wind blows from water to land, the general warms or cold those region with such latitude. Western Europe should have a fairly cold climate. However, a warm water current, North Atlantic drift, warms air above it, giving Western Europe a moderate climate. Because warm air carry more moisture than cool air, the air that flows over Europe is loaded with water vapor. People in these rainy parts of the world need raincoats and umbrellas. Seasons. Most climates along the equator are hot all year round because of direct sunlight we receive. Climates in other places on Earth change with the season because of Earth's tilt. Look at the diagram above. In January, the northern hemisphere is tilted away from the sun, which causes winter there. In July, it is tilted toward the sun, which causes summer. The southern hemisphere's reserve season because it tilts of the opposite direction from the northern hemisphere. Exploring Earth's climate patterns. You have just had a quick tour of forces that affect Earth's climate. Take a place on a globe. Think, think about the factors that affect its climate. How far it is from the equator? How is it? Is its elevation high or low? Are the mountain or a large body of water nearby? What season is it there right now? If you can't answer the question, you can probably guess what the weather is like there, even without leaving your home.